Single-shot RAG is officially broken. If your AI agents and production pipelines are still relying on traditional vector embeddings to retrieve answers, you're paying a massive 33% token tax for answers that fail 73% of the time on real-world enterprise data. Today, Mistral AI dropped Agentic Search, a ground-up reimagining of how large language models interact with documents, turning blind semantic retrieval into an active, file system-style exploration loop. Before this video ends, you're going to see exactly why standard vector chunking fails on complex documents, the architectural mechanics of the 5 specialized tools that power this new loop, the benchmark truth behind an 86% accuracy score on FinanceBench that outperformed Anthropic's Claude Code harness by 10.5 percentage points, and the exact step-by-step developer blueprint to wire this open MCP server in a Cursor, Claude Code, or self-host it with Vespa on your own private infrastructure today. Let us start with the core problem that every AI engineer has quietly run into, the fundamental failure mode of one-shot RAG. When you build a standard RAG pipeline, you take your documents, whether they're 500-page SEC filings, treasury bulletins, or technical manuals, and you chop them into static, arbitrary chunks of 500 or 1,000 tokens. Then, you pass those chunks through an embedding model and store them inside a vector database. When a user asks a question, your system performs a single cosine similarity search, grabs the top 3 or 5 chunks, and stuffs them into the prompt context. In toy demos with simple paragraphs, this looks magical. But in enterprise production, it completely collapses. Take a standard 10K balance sheet. A single financial table contains hundreds of interconnected rows, columns, and footnote references spread across multiple pages. When naive chunking splits that table across token boundaries, the spatial and mathematical alignment is permanently destroyed. The model has no idea which column header maps to which row value. Even worse, if the answer requires cross-referencing a revenue figure on page 12 with a risk factor footnote on page 84, a single-shot vector query will almost never retrieve both chunks simultaneously. The model is forced to guess, leading to hallucinations, or the agent fires a blind requery loop, burning thousands of unnecessary tokens without ever converging on the right page. This brings us to our first critical takeaway. Vector similarity measures lexical and semantic closeness, not document hierarchy or numerical reasoning. If your pipeline cannot actively navigate a document's internal structure, your accuracy ceiling is mathematically capped below 30%. This is precisely where Mistral's Agentic Search enters the arena. Instead of treating documents as passive, fragmented vectors, Mistral transforms the retrieval process into an autonomous, interactive file system exploration loop. When an agent running Agentic Search receives a complex question, it does not just guess in a single shot. Instead, it is equipped with 5 specialized programmatic tools. First is the search tool. This executes an initial hybrid query, combining dense vector semantics with sparse BM25 keyword matching across your index document library. Second is the open tool. Once the agent identifies candidate documents, it opens the target file, loading its structured table of contents, section hierarchy, and page metadata into memory. Third is the navigate tool. Rather than dumping raw text into the context window, the model can dynamically jump to a specific page number, jump to a named section heading, or target a precise bounding box coordinate area inside a PDF or document layout. Fourth is the read tool. At that target location, the agent reads only the clean markdown text and perfectly structured table rows needed to answer the question, preserving spatial alignment without bloating the context. Fifth is the grep tool. If the model is hunting for a specific transaction ID, balance figure, or regex pattern, it runs an exact regex search directly inside the open document, returning line-level matches in milliseconds. And connecting this entire cycle is a crucial parameter called exclude_IDs. When the model determines it needs to gather more evidence, it fires a subsequent search turn while automatically excluding already inspected chunk IDs. This eliminates redundant cycles, prevents infinite search loops, and allows the agent to paginate across hundreds of documents with surgical precision. Now, this architectural shift introduces a dramatic performance difference that we can measure directly in the telemetry. Let us look at the hard benchmark numbers. On FinanceBench, a grueling evaluation suite consisting of 368 real-world SEC filings and 150 complex numerical questions, standard one-shot RAG achieved an accuracy score of just 26.7%. When powered by Mistral's Agentic Search, that exact same evaluation jumped to 86.0%. That is a massive 3.2 times improvement in correctness. On OfficeQA Pro, a benchmark built on nearly 100 years of table-heavy U.S. Treasury bulletins spanning 696 multi-page documents, the gains were even more staggering. Testing on the GLM 5.2 reasoning model, standard RAG scored a dismal 6.3%. With Agentic Search, the score leaped by 45.6 points up to 51.9%. On Mistral Medium 3.5, accuracy gained 27.1 percentage points. And here is the metric that should catch the attention of every AI developer. Mistral benchmarked their Agentic Search harness directly against Anthropic's Claude Code Retrieval harness on the exact same underlying GLM 5.2 model weights. The Claude Code harness scored 41.4% on OfficeQA Pro. Mistral's Agentic Search harness scored 51.9%. That is a 10.5 percentage point advantage purely from the efficiency of this 5-tool navigation architecture. So what is the bottom line engineering takeaway? The quality of your agent's output is no longer bottlenecked solely by model parameter size. The retrieval harness and navigational tooling you place around a model dictate over 50% of its real-world problem-solving capacity. Beyond raw accuracy, this multi-step loop delivers a massive breakthrough in token economics and latency. Under traditional multi-agent setups, models that fail to find an answer will trigger blind retries, bloating prompt tokens, and driving up API costs. Because Mistral's agent navigates directly to relevant sections and filters out visited chunks with exclude_IDs, token consumption dropped by 23.9% on Mistral Medium 3.5 and 33.7% on GLM 5.2. At the same time, end-to-end response speed saw a dramatic leap. On FinanceBench, P90 latency was slashed by 39.6%, falling from 255 seconds down to 154 seconds, while mean latency dropped from 108 seconds down to 71 seconds. You are getting over 3 times the accuracy in nearly half the time, while saving 1/3 of your token bill. Now, let us bridge this directly to how you can execute this in your own production workflows today, the top 1% developer blueprint. Unlike proprietary search engines that lock your data inside closed ecosystem walls, Mistral has released this entire framework across 3 accessible tiers. Tier 1 is the open-source Mistral Search Toolkit SDK. Available in Python, you can install the package and initialize an agentic search engine with just 4 lines of code. You define your model, specify your tool array, including search, open, navigate, read, and grep, and set your maximum iteration depth. The engine handles tool calling, chunk exclusion, and citation verification automatically. Tier 2 is the Open Model Context Protocol server. By configuring a simple MCP_server's entry in your Cursor or Claude Code settings, your coding agent gains native access to your private document libraries. When you ask Cursor to verify an API spec or check a regulatory constraint, the agent autonomously navigates your local repository documentation using the exact same 5-tool loop. Tier 3 is Enterprise On-Premise Deployment. For organizations handling confidential financial, legal, or medical records, you can self-host the entire retrieval backend using Vespa. Vespa provides the hybrid vector and lexical indexing layer, while the open-source MCP server coordinates the agentic navigation entirely behind your corporate firewall, ensuring zero external data egress. To summarize the strategic landscape, one-shot vector RAG is no longer sufficient for high-stakes enterprise applications. By giving models the ability to search, open, navigate, read, and grep documents dynamically, Mistral's Agentic Search eliminates the retrieval bottleneck, slashes token costs by 33%, and sets a new frontier standard for grounded AI reasoning. If you found this technical breakdown valuable, hit the like button, subscribe to the channel, and check the description below for links to the research dossier, SDK repositories, and MCP configuration files. Build smart, execute fast, and I will see you in the next masterclass.